Hello, here we're going to look at 5.6, solving radical equations. The why is we've seen various equations that involve square root and cube roots, such as gravity-based problems and volume. This lesson allows us to solve various equations involving radicals. So I've got some steps here for us that you can see. The key step that's going to be important for us is to isolate the radical. We're going to be solving equations with sets of opposites, addition and subtraction, multiplication and division. So you can see that in this first example here, the first step was that they addressed this -4. They added 4 to both sides. The next step is they addressed this 2. They divided 2 on both sides. And what that did was it isolated the radical to where the radical is on one side of the equation, so that we can take the next step, which would be to square each side. And that's what they did here. When they squared and squared, the square root and the squared are opposites, so it left us just with the 4x plus 8, and 6 squared is 36. So that's going to be the steps that we're taking to solve these. Now, one thing that we will need to do specifically on these types of problems is check the solutions. There are going to be various examples that we'll look at and that you all will run into to where you find extraneous solutions. And those are solutions that we find on paper but don't actually satisfy the original equation. And extraneous solutions come about any time that you take an equation that was initially one type of equation and changed its forms. So in this case, this is a radical equation because it has a square root in it. The equation that we solved right here, however, is just a linear equation. So what that means is that somewhere in between here and here, some type of step might have been taken that causes the solution we find to not actually work. That's called extraneous solutions. So you'll see that we will need to double check all answers that we find to make sure that when you plug it back into the original equation, you get a true statement. The second example is a double scenario. We're going to come back to it in a moment. These are much tougher, but you will see that they found two different solutions. When they checked the first one, it did not work, which means that this solution here is extraneous. The second one did work. So we'll want to just keep that in mind, that we must check our solutions on these to verify that they are in fact going to work. All right. So let's go ahead and jump on in. Let's solve each equation. The first step is always isolating the radical. So I'm going to subtract 8 from both sides. And we'll get the square root of x plus 1 is equal to -6. Now that the radical is isolated, we're going to square both sides. And with that, we'll have x plus 1 is equal to a 36. And when I subtract 1 from both sides, we'll get that x is equal to 35. I encourage you to pause the video here and take a look back at the steps and make sure that you're comfortable with them. If not, rewind the video to watch us work through that problem again. What I'm going to do now is I'm going to go back to the original problem, and I'm going to check if I plug in 35, does it work? So we get 8 plus the square root of 36. Square root of 36 is 6. And then you'll see that 8 plus 6 is 14. 14 is not equal to 2. What this means is that this solution is extraneous. It's not going to actually work. The reason for that, if you look back at this scenario right here, you'll see that we had a square root equaling a negative number. That can't happen. Now, once we squared it, we changed it to a linear equation. This linear equation has a solution. It's 35. But that 35 does not make this part true. So that means it doesn't make the original part true either. So you'll really want to double check your solutions at the end, and not just because I want to see if I made any mistakes, because sometimes the answers literally are not valid, and you have to double check to see if it's real or not. This one does not have a solution. So what you do is you'd still list this one. It's extraneous, so you'd mark it off. This one ends up having no solution. Let's check out some more. On this one, first step is to isolate the radical. So what you'll want to do is, first step, subtract that 1 from both sides. So now we have 14, right? We subtracted 1 from both sides. Whenever you have a number out in front, that's division. So we have square root of 3x plus 4 is equal to 7. We're ready to square both sides. And we'll get that 3x plus 4 is equal to 49. I'll subtract 4 from both sides. And then when we divide by 3, we'll get that x is equal to 15. Now remember, we must check this x is equal to 15 back in the original version. So I've got 2 times 3 times 15. Let's see what happens. 3 times 15, there should be a 15 here, is 45. 45 plus this 4 is 49. Square root of 49 is 7. 7 times 2 is 14. 14 plus 1 does give us the 15. This answer is, in fact, a valid solution. Let's do one more here to be safe. First step, we're going to subtract 12 from both sides. We'll get the square root of 2x minus 1 is equal to negative 8. Now, if you're very mathematically grounded, you know that this one's already not going to have any solutions because I have a square root term equaling a negative number. For the purpose of understanding this section, though, I'll continue to solve. So now that I isolated the square root, we'll square both sides. We'll add 1 onto both sides. And we end up here getting x is equal to 65 over 2. And we're fully anticipating this one to not work. And let's show why. So we have 2 times our solution, which was 65 over 2. It's supposed to equal 4. Well, 2 times 65 over 2 is just 65. So we'll get the square root of 64, which is 8. 12 plus 8 is 20, which does not equal 4. So there's the proof that it does not work. That's the solution that we found on paper, but it is extraneous. And we knew that was going to happen because here in the red, this square root term was never going to equal a negative number. Square roots can only yield us positive answers unless we're working in the imaginary set, which isn't the case in this chapter. So, don't forget to check for extraneous solutions. Think about domain and range as the y. Remember that when we're graphing square root functions, their natural form looked like this. They started at 0, 0, curved up like that. The domain was not all real numbers. It was not all real numbers, which means that every x that we find might not work. Sometimes values of x might be things that weren't possible. Now these graphs up top are going to look different based upon their values, but this one's domain would be x is greater than or equal to 0. There's lots of numbers that wouldn't work for this. If I picked any negative x values, it wouldn't be able to solve this equation because they're just not there. All right, so that's why you need to be on the lookout for extraneous solutions with this type, because the domain and the range in this one was also that y was greater than or equal to 0. With these having restrictions, that means you must double check your solutions. As we move on to the second page, rewatch any first scenarios that you might be confused on because these are about to get a little bit more tricky. Let's talk about some double scenarios. And that's going to be in contrast to the previous page, a little more difficult to isolate the square root. When you're looking at the first two examples under this heading, there's square roots, there's multiple pieces. Our goal is still, in a sense, to be isolate the radical. That means we might need to use different sides of the equations. So for example, I'm going to go ahead and add this piece to both sides. I still need to isolate my radicals. It's just if there's multiple pieces, they're going to need to be on different sides of the equal signs. All right. So once we do that, we are now clear to square both sides. However, you must isolate the radical before you take this step. If you try to square it too early, squaring this is more complicated than you think. It would be multiplying it by itself twice, which means you'd have to FOIL. That's going to be very complicated. Don't do that. Instead, don't square right away. Get each radical isolated onto its own side of the equation, because now when I square it, they both simply cancel out. I'll add 4 to both sides. I'll divide by 5 to get that x is equal to 5. Same rules apply on this page. We need to make sure that these answers satisfy the original equation. When I take that 5 times 5 is 25 minus 4 is 21. I get a square root of 21 minus the square root of 21 is equal to 0. Those cancel out. He is true. So don't be intimidated by the double scenarios. Make sure that you get each square root onto its own side of the equation, just like this. This one's already ready. They're both on their own sides, so we are prepared to square them. When we do this here, I'll subtract 7x from both sides, and we'll get that 4 is equal to -9. Now, this one is already not true, so this one is no solution. We don't even find a solution to double check. The variables canceled out, and this is a linear equation review. Anytime your variables canceled and you are left over with an untrue statement, it is no solution. And that because it means these linear pieces were parallel, which were two lines that never crossed. If you were to graph these original two scenarios, now I'm just making sketches, they'd look something like that. They would also never cross. Now they're not lines, so they can't really be thought of as parallel, but they would in fact never cross. So even when I square both sides, it would turn it from a graph that looks something like that to two parallel lines, still yielding us no solutions. So we'll cover some more of these different types, cube roots, 1/4 exponents, which is really just the fourth root, and then some difficult double scenarios. And then that will wrap up the equation solving portion of this section. That will be a second piece administered at another time.